how fluids work and how we can then apply that to back on Earth. Over. Yeah, I really enjoyed watching the rugby up here, and I was very grateful to get it set up, and I assure you it probably wasn't a better picture than the one you got back on Earth. Every time we change over satellites up here, the picture drops out, and that can sometimes be for about 5 or 6 minutes. So I'm sure you had a better picture on Earth. Over. I take this. Well, actually, you know, we quite enjoy our physical training. It's a bit of a break in the day from our other work, and so we're able to go, and it's quite nice to be able to burn off some energy. And also, our physical training takes place near the cupola window, so it's a chance to be able to work out and look out the window at the same time. Over. I hope to be, within about 2 weeks, I hope to be feeling pretty good and feeling back to normal. Although it will actually take up to 1, maybe 2 years for my bone density to fully recover from this 6-month mission to space. Over. Hi, Kelsey. Well, you know, the other day we had the Cygnus vehicle departed, and also, of course, last week our 3 friends departed in their Soyuz spacecraft and returned back to Earth. And we were able to watch them. They actually went overhead, over us, and then in front of us. And we were able to watch them for a long, long way. Much further than you would have been able to see them back on planet Earth. And again, because there was no obscuration between us and the other spacecraft. And they ended up being like a small star with the sun glinting off their solar panels. So it's incredible how far you can see in space without because we work out regularly, we get an idea of if we're losing strength or if we're gaining strength, and that's really the only gauge we have of our muscular strength. But of course, it's all the small stabilizing muscles in our back and in our legs that we won't really be able to tell how good or bad they are until we get back to Earth and then start standing up and walking. Over. Hi Callum, great question. We have a big pump that pumps air out of the airlock and into the rest of the space station when we depressurize the airlock and takes it almost to vacuum. And then we do lose a little bit of air just for the last portion going to vacuum. And then when we repressurize the airlock, we take the extra air that we're pumping into the space station and use that to repressurize the airlock. A lot of this stuff that we're doing right now will take years to understand the results, but one of the most exciting discoveries we've done up here is using the airlock for science as a hyperbaric chamber.